Hi everyone, welcome to Tpock's AP Microeconomics Review Series. Over the years of teaching AP Microeconomics, I have found that one of the best ways to learn the concepts is by practicing multiple choice questions. So keeping that in mind, I have developed 180 brand new MCQs, 30 for each of the 6 units. I have also provided detailed explanation videos for all of these 180 MCQs, and I am compiling them into 6 different videos. Each of these videos will be covering each of the 6 units of the AP Microeconomics syllabus. Now, if you want to try the MCQs first before looking at the solutions, you can go to www.tpock.com and sign up for this free course that I have where you can attempt all these 180 questions in a quiz format. The link is provided in the description section. Now, please subscribe to this channel if you want to be notified whenever these new videos are being uploaded. Now, without further ado, let's jump in to Unit 1. In this question, we are being asked, what is the root cause of why economies don't produce every single thing its citizens want, but rather is forced to pick and choose what to produce and what to consume? Now, if you're familiar with the topic of scarcity, you will realize that this is just another way of expressing that topic. So if you recall, scarcity is a situation where people's wants are always greater than the resources available to meet those wants. Now, resources available can be massive in amount, but the point is, just by human nature, the amount of things that we want will always exceed whatever we have available. So therefore, since wants will always exceed whatever is the amount of resources available, we have to pick and choose what to produce and what to consume. This means for this question, the correct answer is C, because limited resources, as it cannot satisfy unlimited wants, that is essentially the definition of what scarcity is, and that is why economies have to make a choice on what to produce and consume instead of producing whatever they want. Now, I want to mention some things here. If you look at the other options, it's not like those statements themselves are incorrect in some cases. For instance, if you look at the first statement, command economies have an incentive problem. That is a correct statement, but that is not why societies have to pick and choose what to produce. So in the AP exam, you will end up seeing options like this that are correct by themselves, but in the context of those questions, they may not be. In this question, we are given 5 scenarios and asked to identify which one of them does not involve scarcity. That means out of the 5 options available, 4 of them involve scarcity while 1 doesn't. So let's start off with the concept of scarcity. It's the idea that our wants will always be higher than the resources available to us to satisfy those wants. Why? Because wants are infinite, whereas resources, no matter how much they are, has to be finite. Okay, with that basic understanding of the concept, let's now try to apply it to these 5 scenarios. Scenario A, purchasing more of a good does not require any trade-offs for consumers. Okay, so before we understand that, let's think about how scarcity applies to consumers making a decision to buy something. So you may have $1,000 with you and you're deciding what to buy. So you may want to buy many more things that those $1,000 will allow you to buy. So that is sort of where scarcity comes in. With regards to a consumer making a decision, right? So if the decision to purchase a good does not require any trade-offs, this suggests that the resources available to you are enough to satisfy all the wants that you have. That is why you're not being forced to give up something to make that purchase. So therefore, this does not involve scarcity, and A is actually the answer to this question. Saying that, it's a good practice to go over the rest of the options and so that we can see how scarcity applies to them. B, consumers have the option to buy a good in nearly unlimited quantities at its current market price. Now remember, when it comes to consumers, scarcity applies in this way. the consumer has limited amount of money to buy things and they have to make choices. So although they have the option to buy as many as they want of a good, doesn't mean they have sort of ran away from their scarcity. Yes, that is available for purchase, but the consumer is deciding which wants of theirs to satisfy within a particular budget that they have. So therefore, scarcity does apply here, although the consumer has the option of buying as many goods as he wants, but it's not like they can buy it. Option C, sellers are willing to sell nearly unlimited quantities of a good at its current market price. Okay, so now we have to sort of apply the concept of scarcity when it comes to sellers. Sellers are producers. They're producing something with resources, and even though they may be willing to sell a huge quantity of a good at some price, it doesn't mean they're not giving up something else. For instance, a singer may be, willing to sell unlimited copies of his music, like maybe a music track. But when he decided to make that music, he still gave up the option to do some other things, maybe concerts, maybe some other career. So whenever sellers are deciding to produce and sell something, they are choosing to give up producing something else. So that is sort of how scarcity applies to sellers. So although they may be willing to sell a massive amount of a particular good at a current market price, it's not like they're not giving up the chance to produce something else. So scarcity does apply to them. Number D, the current market price of a good is very high. Now this is a tricky one because when you think of a good having a very high price, you're likely thinking, oh, it's probably not that common in the market. There's a small amount of them. They're sort of trying to play on this idea of scarcity, how it is explained in English language. So when you use the word scarcity in regular English, you are talking about, oh, that good isn't available in large quantities. But that is not how scarcity is defined in economics. So while a good's price can be high, when a consumer decides to buy that, well, they are giving up the chance to buy a bunch of other stuff. When a seller is deciding to produce that at the high market price, they're also deciding to forego some other things they could have produced. So scarcity does apply here, and the market price is not relevant. Lastly, a good is being offered for free by a charity. How does this involve scarcity? Even if something is given for free, that there is an opportunity cost of doing that. So what do I mean by that? So when the charity decided to give away some good for free, they could have decided to give something else away for free, but instead they opted for that. For instance, a charity may decide, should we give warm clothes or should we give food? So a charity has a limited amount of resources available. With that money they have raised, they can decide to provide food for people, or they can decide to provide shelter for people. Just because it's being given for free doesn't mean scarcity was not involved here. So that explains how in these 4 options we see scarcity in action, but the first one does not involve scarcity. So that would be the answer. In this question, we are given 5 options and asked which one of them most accurately describes the concept of opportunity cost. So what is opportunity cost? Opportunity cost is the next best thing that you give up when you make a choice. So let's do an example. In the 5 minutes that you're spending to watch this video, you could have done a few other things. You could have, seen a funny video on TikTok, or perhaps just scrolled through Facebook. So among all these options that you had available, and you only had 5 minutes of time to spend on them, and you can't do all of them, you have to make a choice. So let's say since you're here, you are choosing to watch this video. So you gave up the chance to see a video on TikTok and also to just scroll through Facebook. So if you did not see this video, it's not like you could have done both of those. You would be picking the next best option. So if watching a video on TikTok was the next best option, in that case, the opportunity cost of watching this video is watching a video on TikTok for you. So that is what opportunity cost means. It's the next best thing that you give up when you make a choice. Now, if you go through the options, The first three are all about production costs. So that is not where opportunity cost comes in directly. Let's look at number D. This is a tricky one. It includes all remaining possibilities that are given up when a production or consumption choice is made. Well, in the context of our example, they're saying, is it the watching the video on TikTok and scrolling on Facebook? Are all of these options that you give up the opportunity cost of making a choice? Not really, because it's not like with that same amount of time, you could have done all of those things. It's the best among those options that you gave up. So therefore, it's not all remaining possibilities. If it said the next best possibility, then yes, D would have been the answer. But since it says all remaining possibilities, that is not what opportunity cost is. If you look at E, since that is the only one remaining, that is indeed the right answer, but let's dig deeper into this. D says it is the quantity of a good that must be sacrificed to produce an extra unit of another good. This is one way opportunity cost can be expressed. Because see here, when this producer is producing an extra unit of a good, they're using resources to do that, right? And that resource could have been used to produce something else. The next best thing that it could have produced, the amount of that is what this producer gave up when they produced an extra unit of a good. So therefore, this is one way of quantifying opportunity cost. Now, of course, this is a production case. You could have had a consumption case or some other case that involved making a choice and giving up the next best thing. But in this context, this is the right answer. In this question, we are given a scenario where a person is making a choice between attending a university versus doing a job. And we are given some values and asked to calculate the opportunity cost of the choice she made. Now, if you recall, opportunity cost is the value of the second best thing that you give up when you make a choice. So in Jane's case, when she chose to go to university, what she gave up was the chance to earn a salary. So you may say, well, by going to university, she gave up the chance to make a salary of $45,000. That is the opportunity cost. Well, not so fast. That would have been the correct answer if there was nothing else involved. She only has 1 year of time. That's the same resource she's spending for the job or for her university. And she's getting some value from her university versus some value from getting the job, which is the salary. So in that case, choosing the university means she was giving up the salary of $45,000. But in this scenario, as we see, it's not as straightforward. Aside from her time that she's spending on both cases, and also living expenses, which she actually has to spend regardless of whether she is attending university or the job, and the living expenses would be the same in both cases because it's a local university, so she's in the same area. So she's using those same resources, but there's one difference here. And that difference is, aside from those expenses that she has to pay for both job and university, she has an additional expense for her university, which is her tuition fee. Now, that money could have been spent in another way as well. So not only do you have to think about what's the value of the job that she's giving up, but you also have to think that she's paying that $22,800 for her university tuition that could have been spent elsewhere as well. So her opportunity cost in this case is going to be the $45,000 salary that she's giving up, and also the money that she's spending on her tuition fee, which is $22,800. Why not the living expenses? Why don't you include that? Well, thing is, by opting to go for university, she has to pay that living expense. But if she did the job, she would have to pay the living expense as well. So that is why we sort of ignored that. And we have our answer of $67,800. That is the opportunity cost of Jane for choosing to go to university and giving up the job. So the answer to this question is going to be E. In this question, we are given a scenario where two people have made their choices while giving up their next best option. So Emily here has opted for local college. That means she has given up the chance to do some other things. We don't precisely know what her second best would be, but I think it's fairly, convenient to assume that she gave up the chance to do a job. On the other hand, Alex here pursued full-time employment. So when he did that right after graduating from high school, that means likely that he gave up the chance to go to college. So we have identified what their next best option would be in the context of the question, but that is not what the question is precisely asking us. It has given us 5 different statements, 3 about Alex's opportunity cost and 2 about Emily's opportunity cost, and they're essentially asking us to identify which one of them is a component of their opportunity cost. Now, sounds very confusing, right? Because we thought opportunity cost is fairly straightforward. What's the next best thing you give up? Well, not so fast. What we saw in the last question when we discussed opportunity cost of going to college and we were calculating values, I gave an explanation that sort of hopefully made sense, but opportunity cost has a particular structure that you should follow. So in this question, I will be explaining you how to generally calculate any opportunity cost. So Emily, when she opted to go to college, yes, she gave up the chance to pursue full-time employment. So how do we calculate her opportunity cost of going to college? Firstly, we will think about all the resources that she's spending by going to college. So she's spending her time, she's spending tuition fee, which could have been spent elsewhere, and she's also paying a living expense when she's attending college. So these are the resources she's spending to do that choice of going to college. So we have to think about the opportunity cost of those resources. Okay, so the value of resources, that's one. Next is, what is the net value of her second best option? So by foregoing full-time employment, she definitely is not going to earn that salary she would have earned. But so that is part of her opportunity cost. But it's not just that salary. Even if she pursued the job, she would have to spend some resources to do that job, right? So as a result, when we think about what she gave up, she didn't just give up the salary, she gave up the net value of that salary. So we have to subtract the value of resources she would have spent on her job from the salary, and then we will sort of get what was the net value of the second best option that she gave up. So in this case, even if she did the job, she would have to spend time and also would have incurred living expenses. So the Emily's opportunity cost in this context is going to be the value of resources she spent on college. So the value of her time, value of tuition fee, value of living expenses, plus the net value of her second best option. So her salary minus the value of the resources she would have spent on that job, which would have been her time and living expenses. Now, as you can realize, when you set it out like that, the time and the living expenses sort of cross out because she would have to spend that for both her job and both college. So therefore, her opportunity cost would simply be her tuition fee that she's spending plus the salary she should have gotten from the job. And that's it. That would be her opportunity cost. So if you look at options D and E, E says Emily's opportunity cost includes her cost of living while she attends college. So you may think, well, isn't it part of the system or part of our equation here? It is, but remember, it actually gets crossed out with the living expense she would have to incur even if she didn't do college, right? So therefore, this would not be the correct answer. If you look at D, Emily's opportunity cost includes the potential salary she could have earned had she chosen to work instead of going to college. That is the right answer. Now, although we have gotten the right answer, you tend to learn a lot more from the wrong answers as well. So let's think about Alex's opportunity cost. Would be good practice. We'll follow the same technique that I just showed. So if you think about Alex's opportunity cost, he made the choice of doing a full-time job. Since it was right after high school, we can reasonably assume that his next best option that he gave up was likely going to college. So what is his opportunity cost of doing the job? First of all, what resources were spent to do the job? So it would be the value of resources. So the time he's spending could have been spent in some other way. And also the living expenses he has to incur while he's doing the job. These are the resources he has to spend in order to do the job. Okay. And what did he give up? Going to college. So there's some value of the college education. We don't know what that value is. It's hard to quantify. You can think of it as the increase in wage he may have seen if he has the college degree or something along those lines. But we can for now say it's just some value he would have gotten from the college education. But even if he give up that value from college education, it's not like he wouldn't have to spend resources to get that education. So you have to subtract from the value of college education the resources that he would have spent on that. So the time he would spend, the living expenses he would have to pay, and also the tuition fee. So as you can see, once again, the time and living expenses sort of cross out, leaving Alex's opportunity cost as the value of resources would sort of cross out. So there's pretty much zero there. And the net value of second best option, so in the net time and living expenses we crossed out. So essentially for Alex, his opportunity cost of doing a full-time job would simply be the value of his college education minus the tuition fee that he would have had to pay. So if you look at the three options A, B, and C, A, Alex's opportunity cost is the salary he's earning from employment. That is not his opportunity cost because he's not giving that up. Alex's opportunity cost is the tuition and expenses he would have incurred for college. So while tuition is part of his opportunity cost, the expenses wouldn't be, right? So that's why B is not the right answer. And C, Alex's opportunity cost is lower than Emily's. Well, thing is, for Emily, her opportunity cost, as we realized, is simply after crossing everything out, was the salary and the tuition fee she was spending. And for Alex, it would be the value of education, the college degree, minus the tuition fee. The thing is, we don't really know the values here, right? So we cannot compare what Alex's opportunity cost was to Emily's, because in this case, what is this value of education? We don't know. What is the salary that Emily could have earned? We don't know. So therefore, you cannot say C is the right answer. So we are left with D being the correct one. I hope this sort of clarified what opportunity cost really is. In this question, we are being asked what capital means when we are talking about it in the context of it being a factor of production. Okay, so what are factors of production? Anything you produce in this world requires resources. And in economics, we divide it into 4 different types. One is land, which is all natural resources. Doesn't really have to be only physical land, right? It can be sunlight, air, anything that's found naturally, that is land. Then you have labor, which is mental and physical effort given by people. Third is capital, which is relevant to our question. Now, capital means any tools or machines that we have produced in order to help us produce something else. So if you think of a tractor or just very basic tools that we use, even a computer or laptop, these things that goes into production, those would be called capital. And the fourth factor of production is entrepreneurship, which is the skill that some people have to bring land, labor, capital together to produce something. So in this context, the answer is fairly straightforward. It is B, which is the tools and machines used in the manufacturing of goods and resources. Well, you would have gotten that answer if you recalled what capital is by definition, but I know you should have some questions. In regular term, when we talk about capital, right, we talk about how much money that you need, right? If I want to set up a business, I will say, oh, I need some capital to set that up. So how does that, connect to this? There seems to be some incongruity there. Well, first thing to remember, every discipline, so economics, business, finance, every discipline have their own terminologies. So they use particular words in a particular context. In economics, the way we use capital is simply anything that is a tool or machine that will help us produce something else. In finance, the term capital may be investment or money that you need for business. So the first thing is, when you think about the term capital in an economics exam, we are asking you how it is used in economics, not in some other discipline. So that's one. Secondly, the more pertinent question may be, why isn't money considered as capital? Don't you need money to produce anything? Well, yes, but the money simply gives us buying power. So if you're stranded in an island and you have $100 with you, that $100 note is not going to help you produce anything. So that's sort of how we think about it in economics. So take out money from an economy, and money is a fairly recent innovation if you think about human history. Do you think that there was no production before that? Of course there was. So when we think about factors of production, we think about only real things that you can bring in together to produce something. So money would allow someone to bring all these factors of to buy factors of production, but even without money, you could still produce things. So that's sort of why we use the term capital as actual things that can help you produce something else. We don't think about money or define it as being capital. In this question, we are being asked which of the following among the 5 options available is true in a capitalist or a free market economy. Now, if you recall, there are 2 distinct types of economic systems. One is the capitalist or free market economy, where people own the properties, resources, etc., and they make their own decisions without government intervention. On the other end of the spectrum, you have a command economy or a planned economy where the government owns everything and makes decision on what will be produced, how it will be produced, and who will get to enjoy those resources. So in a free market economy, the way resource allocation works is that through price of a good, when price of something goes up, that gives us some information. Prices, can be seen by everyone, the price of a good. And when the price of something goes up, it tells everyone that it's perhaps likely in high demand. And when price of something goes up, you'd expect sellers or producers to allocate more resources to the production of that good. And if something is not really in demand and people don't want it, you would expect price to fall, giving a signal to the market. So without any coordination by the government, price itself can allocate resources pretty well. So that's the whole idea behind a capitalist or free market economy. And therefore, if you look at the options, A is the right answer because prices act as motivations for the allocation of factors of production to markets where their value is highest. So resources will flow where they're valued the most, which everyone can see because prices are visible. Now, you may think B might be an answer. Prices of goods and services are coordinated by the invisible hand. That is true in a free market economy. That is a correct statement. An invisible hand is something that we say to suggest that although there is no visible hand of the government coordinating everything, just the fact that the price can sort of give people signals means that the market tends to get coordinated by itself. So that is where the invisible hand comes in. And this is sort of a trick question because you see invisible hand, you think, oh, that's free market, and you write that answer. But you should read the remaining part of that statement. It says prices of goods and services are coordinated by the invisible hand of the market. That is true in a free market system to achieve an equal allocation of private property. That means everyone gets the same amount of private property. Now, as you know, equal distribution of goods and services or even properties, that is something you would think may happen in a planned economy. Although in a planned economy, property rights are usually with the government. But in general, equal distribution is not something that happens in a free market or capitalist economy. So if you look at option B, it is full of the keywords or jargon that you would expect to be associated with capitalist or free market economy. But if you read the lines carefully, you will see this cannot be the correct answer. C, the factors of production are all publicly owned. That is something that you would see in a command or planned economy. The goods and services produced are distributed based on needs. That is something that planned or command economy perhaps aspires to, but that is not something that happens because the government can never have that much information about who actually needs the good the most. So that's sort of why this is something that's not actually even possible for in either free market economy or a planned economy. Lastly, the government is elected through a fair, inclusive, and transparent election process. Technically speaking, this is nothing to do with the economic system. We tend to see in a free market or capitalist economy, they're more democratic in nature, whereas command and planned economies are not. But while this is sort of something that you tend to see in capitalist or free market economy, theoretically speaking, you can have a dictatorship with a capitalist or free market economy. So therefore, this is not the right answer either. This question is about production possibility curves or production possibility frontiers. We are given a diagram that shows the production possibility curve of econ land. The country can only produce consumer goods or capital goods, and we see the different possible combinations that it can produce at a maximum. In other words, production possibility curves show the production capacity of an economy. The economy is currently producing 60 consumer goods and 80 capital goods. So if you go along the consumer goods situation, it's producing 60 and it's producing 80 capital goods. So if you go by that point, it is currently producing on the production possibility curve. It is producing at capacity and it's producing this combination. So the question asks, which of the following combinations would most likely lead to greater economic growth for econ land in future? So economic growth is a key concept here. So let's recall what it means. In the economic growth just means an economy is able to produce more than before. So if you're trying to capture how economic growth would look like in a production possibility curve, it would mean that the production possibility curve has shifted outside. The production capacity has increased. So how does the production capacity increase, or how does production possibility curve shift to the right? There are two things that will help make that happen. The first is the amount of resources available to the economy should increase. So if it has more land, labor, or capital, in that case, production possibility curve will shift to the right. Or the economy can have better technology. That means it is able to use its resources in a more efficient and better way, allowing it to produce more with the same amount of resources. So how does this connect to this graph? We are not told anything about efficiency or technology improving, so it has to do with resources increasing somehow. Now look at what this economy is producing. Consumer goods or capital goods. Capital goods, if you recall, are tools and machines that help you produce more goods. So in this case, currently this economy is producing 80 capital goods. If it tends to produce more capital goods, we would expect that it will have more tools and machines available. In future, with the higher amount of resources, it should be able to produce more. On the other hand, consumer goods are consumed right away. So therefore, the more capital goods the economy produces, we would expect a higher rate of economic growth. So if you look at the options available, it should be capital goods that are greater than 80. So you have two options here. So it's either between C and D. So among C and D, D has the higher amount of capital goods. So in that situation, we will say D is the correct answer. In this question, we have been given a production possibility curve of econ land, and we are told that the country is currently productively efficient. So let's think about what that means. Productive efficiency means, in the context of a production possibility curve, that the country is producing on its PPF. So it's producing anywhere on its PPF. We don't know exactly where. The productive efficiency term simply means the country is producing at a point on its PPF. Okay. So now that we've established that, the question says, calculate its opportunity cost of increasing production of capital goods from 80 to 120 units. So if it is currently producing at 80 capital goods and it is productively efficient, so we'll go up to the production possibility curve and find that it was currently producing here at point A. Now, if it increases its production of capital goods from 80 to 120, it means it needs to divert resources away from consumer good production in order to do so. because once again, resources are limited. So you come from here to here. So by increasing production of capital goods by 40 units, how much consumer good production did Econland give up? Well, it gave up 20 consumer goods because it diverted those resources away from consumer goods to producing 40 capital goods. So therefore, the answer is A for this question. In this question, we are being asked, which economics principle are we ignoring when we draw a straight line PPC? Well, the key concept here is a straight line PPC. So let's think about what it means. When you have a straight line PPC, it means the opportunity cost of producing either of those goods is constant. So for instance, if you start out at point A here, and let's say you increase production by a certain amount, then your good Y production, so you increase good X production by some units, good Y production will fall by some units. Now that ratio is constant throughout your entire journey. So if you sort of increase production of X by the exact same amount, Y will fall back by the exact same amount as before. So if it can be 1x for 2y or 1x for 3y or any ratio it may be, but regardless, this ratio will stay fixed while you continue increasing production of X. And that applies if you go the other way as well. So why do you have, or in what situation do you have a straight line production possibility curve? It boils down to resources being identical to each other. So think of 100 workers that are available. Each of them can produce 1x or 2y. And therefore, when you drag one person away from production of y to production of x, regardless of whom you pick, all these 100 workers are identical, you will get the same opportunity cost as you keep reducing production of y and increasing production of x. Now, in reality, that does not happen because resources are not identical. Some workers are perhaps good at producing agricultural goods, some are great at producing manufactured goods. So the opportunity cost of these workers are not really the same. And this sort of gives us an economics principle called law of increasing opportunity cost. It means if you are drawing a production possibility curve, the production possibility curve will have a bowed outward shape, and as you keep increasing production of X, the amount of Y that you give up increases drastically for the same amount of X being increased. And that is because you have different kind of resources in an economy. So when you produce, let's say you use all your resources to produce good Y. When you start producing good X, you will get those specialized in X people first. So Y doesn't fall much, X increases a lot. But of course, there are only so many X specialists in an economy. So as you keep drawing away resources from good Y production and allocating them to good X production, you'll be giving up more and more of Y as you sort of divert all resources to good X. And in this process, you will see that the amount of Y you're giving up creeps up, it keeps going up. So whenever you draw a straight line production possibility frontier, you're implicitly assuming that all resources available in the economy are identical to each other with constant opportunity, with the same opportunity cost. So that is the principle that you're violating, which is the law of increasing opportunity cost. Now, this law is reflected whenever you draw a bowed outward or a curved PPC that I have drawn up here. Let's look at the other stuff, because I think, as I said before, you learn a lot from the wrong answers as well. So the law of invisible hand of the market. This is just about how price in a market that is visible to everyone helps coordinate all production and consumption in an economy. So as a result, that is not about PPC. The second principle of economics, there's nothing like that. The law of opportunity cost. So this is something they're trying to trick you. If you forgot which way the opportunity cost should be going, you may be tempted to pick that. But there's no law of opportunity cost. There's only law of increasing opportunity cost. And that sort of explains why D is also incorrect. In this question, we are told about an economy that produces only two goods, food and housing. And we are asked what would cause its production possibility frontier or production possibility curve to shift outward. So let's think about what it means for production possibility curve or frontier to shift outward. It means the country's production capacity has increased. It can produce more of both food and housing. So how does that happen? There are two things that will make this possible. The first one is when the quantity or quality of the resources or factors of production available goes up. So that means the country either has more land, labor, or capital. Since it has more resources, it can produce more. Or it has better quality land, labor, or capital. So maybe the quality of land improved, or maybe the quality of the workers improved, or maybe the quality of machines improved. In those cases, the country has greater production capacity than before. So that's one, which is quantity or quality of factors of production. The second thing that can make this happen is an improvement in technology. So technology in economics doesn't mean cell phones and laptops and internet. It's the skill and knowledge that people in an economy have in how to convert resources into goods and services. So if farmers have figured out how to grow a crop 3 times a year compared to 2 times before, in that situation, they now know how to use the land, labor, capital available to them in a better way. So that is how we talk about technology. So you may ask, what about cell phones and internets? Aren't they increasing the efficiency? They are. So they are allowing us to use our resources better. So that is why when we see more cell phones, laptops, internet, and more innovations happening in that space, that is allowing us to be more efficient, allowing us to use our resources more efficiently. All right. So among the options available, we need to see, are they affecting quality or quantity of factors of production, or are they improving the technology? So let's look at it. So for the first 3 options that we have, all of them talk about changes in the prices of goods. Now, prices of goods changing has nothing to do with the resources available in the economy, right? So as a result, the change in prices of goods will have no effect on the production capacity of an economy, which is the production capacity is actually drawn assuming all resources are being used to produce either of those 2 goods, right? Okay. Number D, a sudden influx of immigrants. So if you think about it, if you have more immigrants coming in, how does it affect the amount of resources available in the economy? It should increase the amount of labor. So that should mean the country's production capacity should increase because now it has more workers available to them. Now you may say, well, yes, so increase in immigrants should increase labor, increases production capacity, but what if these workers or new immigrants who are coming in are not working? Should the production possibility curve shift to the right in that case? Well, thing is, the production possibility curve doesn't actually show you where the economy is producing. Think of this diagram that we have drawn. Think of the first PP production possibility curve that we have. The country may be producing nothing. So that's the production point. It can choose to produce nothing. The production possibility curve shows the production capacity. Think of a factory. It can choose to produce nothing, but it still has the ability to produce up to a certain point. So that is what production possibility curves show. It shows our capacity to produce, not where we are currently producing. So therefore, a sudden influx of immigrants, whether or not they are working, would lead to the production possibility curve to shifting outward because the production capacity should be increasing. Okay. What about E? Prolonged drought that affects farming. So if there's a prolonged drought, you would expect the quality of land to deteriorate. It should get worse. And if the quality of a factor of production is affected, it should reduce our production capacity. In that case, PPC would be shifting inward. So that is not the right answer either, leaving you with D, which is the right answer to this question. In this question, we are given a straight line production possibility curve and asked what is happening to the opportunity cost of producing X or Y in this diagram. Well, if you remember, a straight line production possibility curve automatically implies that the opportunity cost is constant, and that opportunity cost is constant for producing either of those goods. So therefore, just by recalling that, you should know the answer to this question is going to be A. But let me sort of show a workthrough of how that happens. So I have divided this graph into two parts. So I've taken the middle point. So if you can produce 180 units of good X at max, maybe the half point would be 90 here. And if you're producing 100 units of Y, then the half point would be about 50. So let's say this is a midpoint, right? So what I will show you is I'll go from A to B, then to C. So when I'm doing that, I'm increasing production of X and reducing production of Y. I will show you that the opportunity cost of producing X stays constant as you move from A to B and then B to C. And then I will go the other way and show that the opportunity cost of producing Y also stays constant. So let's start. If I go from A to B, that means what? I have increased good X production by 90 units. And as a result, I have decreased good Y production by 50 units. So to produce this 90 units extra of X, I had to give up production of 50 Y. So that means to produce 1 unit of X, I had to give up 50 over 90 Y, which happens to be 5 over 9 Y. Okay, so that is from A to B. Let's now move further down. So if we go from B to C, good X production goes up from 90 to 180. So you got an additional 90 units of X. But again, to do that, you had to reduce good Y production. So you reduced good Y production by 50 units again. So to produce 1X, once again, you had to give up 5 over 9Y throughout this entire segment. So this shows you that despite increasing production of good X, good Y production did fall, but that rate at which it was falling stayed constant throughout. Okay, so what we have established with these numbers is, in this graph, the more X you produce, Y production will fall by the same amount. Okay, so that shows me constant opportunity cost while producing X. What about the other way? Well, to see that, we will go from C to B and then from B to A. So we'll go the other way. So if I go from C to B, what I see is I have increased production of Y by 50 units. So I was producing 0Y here. Now I'm producing 50Y. Now, while doing that, I had to give up 90 units of X. So for 1 unit of Y, I gave up 90 over 50X or 9 over 5X. Okay. Now, what if I go from B to A? So to go from B to A, same scenario. So I was producing at B here. If I increase Y production by 50, again, I had to give up 90 units of X. Okay, so that ratio of 1Y equals to 9 over 5X stayed the same. So as a result, we can see that with a with a straight production possibility curve, opportunity cost of producing X and Y will remain the same no matter whether you're producing X or Y. And therefore, A is the correct answer to this question. In this question, we are being asked what happens when an economy experiences an improvement in technology. Now, technology is the skill and knowledge that people have in how to convert resources into goods and services. So when there's an improvement in technology, that means the economy or the people within it have learned how to use their resources more efficiently. They can get more out of those resources or produce more using the same amount of resources. So when this improvement in technology affects all goods, that means the economy can produce more of both machines and food than before. So it can be other goods as well, but machines and food are something that I'm using as representative goods that this economy is producing. But when you have an improvement in technology in producing all goods, that just means the PPF shifts outward. So therefore, the answer to this question will be C. However, let's go through the rest of the options to see what we can learn from them. So a steeper or flatter production possibilities curve. Now this can happen if you see an improvement in technology in one particular good. So for instance, so let's say you see like farmers have figured out how to grow crops 3 times a year instead of twice a year. Now this is an improvement in skill and knowledge only in the farming industry, not in the machine production industry. So that would mean at the maximum, however much food the economy could produce, now it can produce more, whereas the amount of machines it could produce has stayed the same. So in that case, the curve can become steeper or flatter, or however you want to say it. If you use this axis, it has become flatter because it has a smaller slope. In that case, you could have had D as an answer. But in this case, since we know this improvement in technology affected all goods, that would not be the right answer. So the same applies for B and D. We can cross them out. What about a decrease in unemployment rate? We have discussed this before in another question, but unemployment rate is connected to the production point on the PPF, not the PPF itself. Remember, PPF shows the production capacity of an economy, and it's drawn under the assumption that all resources are fully employed. So you may be producing nothing. In that case, your production point will be on the origin. However, the PPF would stay the same because the PPF was drawn assuming everyone was working or resources were fully employed. So when you see a decrease in unemployment rate, yes, then that means you may be producing more than before as more people are working now. Maybe you're producing closer to the PPF, but this does not affect your production possibility frontier. Okay, an inward shift of the PPC. So an inward shift of the production possibilities curve happen when the technology decreases or the quantity or quality of resources decrease. So since none of that happened here, you can leave that out as well, leaving you with C as the right answer. This question is about comparative advantage and trade, and it is one of the easier questions that you can come across in your AP Microeconomics exam. So let's get started. So if you look at the options that are available to you, there are 2 concepts that spring out. So one is comparative advantage, another is absolute advantage. We'll start with the latter because that's really easy to find out. Absolute advantage is when a country can produce a good more efficiently than the other country. So what does that mean? So that means using the same amount of resources, a country can produce more of a good than another country. Hence, it's more efficient. So if you look at the table, capital good production, country A can produce 20 units and country B can produce 10 units. Now, that doesn't mean country A has absolute advantage right away. You have to check whether both countries are using the same amount of resources or not. So in this situation, despite having the same resources, country A somehow is able to produce twice as much of capital goods than country B. So therefore, country A does have absolute advantage in capital good production. Now, what about consumer goods? Well, same story here. Country A can produce 50 units of consumer goods, whereas country B can produce 20 units. And since they're using the same amount of resources, we can deduce that country A is indeed more efficient at producing consumer goods as well. So in this story that we have been given, country A has absolute advantage in both goods. When you see questions like this on comparative advantage and absolute advantage, it's a good idea to check whether the absolute advantage answer that we found is correct or not. That will help you save time in the exam. So let's see. Option A says country B has absolute advantage in both goods. We know that is not correct. Country A has both an absolute and a comparative advantage in capital good production. Country A does have absolute advantage. We know that in both goods, but we don't know about comparative advantage yet. Country A has absolute advantage in capital good production. Once again, it's talking about comparative advantage here. We don't know. Country B lacks absolute advantage in the production of either good. That is a true statement. But again, we don't know anything about comparative advantage. The last one is country A has an absolute advantage in capital good production, but terms of trade information is needed to justify any comparative advantage. We will not be discussing terms of trade in the explanation of this answer, but you need to find comparative advantage first before you can talk about terms of trade. So therefore that would not be correct, as we will see later on. But anyway, so what we have deduced so far is finding out absolute advantage does not give you the answer to this question. So this takes us to the next aspect, which is what is comparative advantage. So comparative advantage is when a country can produce a good at a lower opportunity cost than the other country. So that means when it's producing, both countries are producing 1 unit of a good, but country X gives up less amount of its other goods production than country Y. So the idea would be a country produces something, same unit of a good by giving up less compared to the other country. So how do you find it when you have a table? Straightforward, you have to calculate the opportunity cost of producing, you pick a good, and then you find the opportunity cost of producing it for both countries. And then you check who has the lower opportunity cost. So who has comparative advantage in the production of capital goods? We need to find opportunity cost of producing 1 unit of capital good for both countries and simply compare who has the lower one. So I have it worked out here. The way you would start is, well, let's pick capital good first. Now, country A, we know, can produce 20 units of capital goods, and when it does that, it gives up producing 50 units of consumer goods. So that's what I have written in the statement here. To produce 20 capital goods, country A has given up 50 consumer goods. Now we will convert it to what, how much consumer good did country A give up when it produced 1 capital good. Now you may ask, why am I converting it to 1 capital good? The reason is you need to see the opportunity cost of country B as well. So you have to sort of compare it with the same amount of unit. So that's why we have converted it to 1 unit. All right. So 20 capital goods is equal to 50 consumer goods for country A. If you do some simple mathematics, you'll see 1 capital good is 50 consumer good divided by 20, which is 1 capital good is equal to 2.5 consumer good. This is the opportunity cost of country A to produce 1 unit of capital good. It produces 1 unit of capital good. It gives up the chance to produce 2.5 units of consumer good. All right. So we know the opportunity cost of country A to produce capital good. What about country B? So for country B, when it produces 10 units of capital goods, it gives up the chance to produce 20 consumer goods. So we write that up and again express it in terms of 1 capital good, and we find country B gives up 2 consumer goods, whereas country A gives up 2.5 consumer goods when they're both producing 1 unit of capital good. So it seems country B gives up less compared to country A, and therefore country B has comparative advantage in the production of capital goods. Okay. Now you can repeat the same process to find who has comparative advantage in consumer goods, but there is a shortcut. And that shortcut is, if one country has comparative advantage in the production of something, the other country must have comparative advantage in the production of the other good. Why is that? It's a long explanation, won't get into that, but you can see that yourself if you follow the same approach and find the opportunity cost of producing a consumer good. You will find that since country B has comparative advantage in the production of capital goods, country A will have comparative advantage in the production of consumer goods. Now, this is a technique that is really helpful in an exam setting because you won't have much time. So you don't have time to do so many calculations. So as soon as you find comparative advantage for one of the goods, you can assume that the other country has comparative advantage in the other good. Now, aimed with that knowledge, let's try to see what the answer to this question should be. So B, country A has an absolute competitive advantage in capital goods production. We know that is not correct because country B has competitive advantage in capital good production. What about option C? Country A has an absolute advantage in capital good. That is a right statement. But a comparative advantage in consumer good production. That is also a correct statement, telling you that C is the right answer. In this question, we are given the production possibilities of Harry and Meghan. They can produce flowers or tea leaves. And we are asked, we're given options on their comparative advantage, absolute advantage, and terms of trade. So let's get started. The first one is absolute advantage. And if you recall, absolute advantage is when someone can produce a good more efficiently than the other person. Right. So in this case, and that has to be done using the same amount of resources. So in a single day, we find that Harry can produce 5 flowers, whereas Meghan can produce 8 flowers. That already tells us that Meghan has absolute advantage in flower production, as she can produce more of it in a single day compared to Harry. So therefore, that will rule out option A. Now, if you look at the remaining options, none of them are about absolute advantage anymore. So let's move on to comparative advantage. So option B says Meghan has a comparative advantage in picking tea leaves. So Meghan would have comparative advantage in picking tea leaves if she produced tea leaves at a lower opportunity cost than Harry. So to figure this out, we need to find opportunity cost of producing tea leaves for both Meghan and Harry and find who has the lower one. If Meghan has the lower one, then B would be correct. If she doesn't have the lower one, then B would be incorrect. Now, instead of actually looking for opportunity cost of picking tea leaves, I will do something different here. I will try to find the opportunity cost of producing flowers for both Harry and Meghan, and I will explain why I did that a bit later. But let's see how that works. So what is the opportunity cost of producing flowers for both Harry and Meghan? So when Harry produces 5 flowers, he gives up the chance to produce 25 tea leaves. So that means to produce 1 flower, Harry gave up the chance to produce 5 tea leaves. On the other hand, for Meghan, when she chooses to produce 8 flowers, he gives up the chance to produce 24 tea leaves. So that means for 1 flower, she gave up the chance to produce 3 tea leaves. So if you compare, Meghan gives up less tea leaves than Harry when producing 1 flower. So Meghan has comparative advantage in the production of flowers. That means Harry must have comparative advantage in the production of tea leaves. Remember that a person, if they have comparative advantage in the production of one thing, they cannot have comparative advantage in the production of the other good. So as a result, we can rule out option B, because option B says Meghan has a comparative advantage in picking tea leaves. That cannot be correct because she has comparative advantage in picking flowers. All right. Now, why did I not start with opportunity cost of producing flowers? This is connected to how you find terms of trade, and let's elaborate on that. So the idea is, when 2 people have comparative advantage in the production of different goods, they will specialize accordingly and sell it. So Meghan, with a comparative advantage in flowers, will produce and sell that. Harry, with a comparative advantage in tea leaves, will produce and sell that. So how do we figure out? So we understand they're buying what they're producing and what they're buying and selling with each other, right? But at what rate is this happening? So for 1 flower, how much are they getting? So for 1 flower, is it 5 tea leaves, for 6 tea leaves, or 10 or 2 tea leaves? So what is the rate that makes both of them happy? And remember, for trade to happen, both the buyer and seller has to be happy. Otherwise, the trade will not happen. The easy answer is to find a term of trade that is mutually beneficial to both. You sort of pick a good. In this case, I picked flowers. Then you find the opportunity cost for that 1 unit of that good. So for Harry, when he produces 1 flower, he gives up 5 tea leaves. For Meghan, produces 1 flower, gives up 3 tea leaves. A term of trade that works for both of them would have to lie between that opportunity cost. So the mutually beneficial term of trade in terms of 1 flower will be something between 3 tea leaves and 5 tea leaves. That is always the way to find mutually beneficial term of trade quickly, but what is the underlying logic behind this, right? So here you go, let's talk about that. For Megan, she's the one who's selling tea leaves, right? So for one, when she produces, she's the one who's selling flowers because she has comparative advantage in that. Now, when Megan sells one flower, she will not accept anything less than 3 tea leaves as price. Why? Because if Harry offers her 2 tea leaves, Megan will say, I will just simply not produce that one flower, and instead I can produce 3 tea leaves on my own production possibility curve. So that is the price I can get from my own production possibility curve. So if you want to buy one flower from me, you must pay something more than my opportunity cost. So therefore, Megan as a seller will not accept anything less than 3 tea leaves. Now, on the other hand, Harry is the buyer, right? He's buying the flower. So if Megan charges him 10 tea leaves for one flower, Harry will say, well, instead of doing that, I can just not produce 5 tea leaves and I will get one flower. So that's the max he's going to pay. To sum it up, to find a mutually beneficial term of trade, you need to figure out, are you speaking in terms of one flower or one tea leaf, essentially which good you're focusing on. And once you've figured that out, the next part is finding opportunity cost of that unit. So we figured out, let's say for flowers, right? So we found the opportunity cost of flowers for 1 unit of flower. And then the mutually beneficial term of trade must be between those 2 values. So therefore, if you look at this answer, the answer would be E. In this question, we are told that Switzerland and USA produce only 2 goods, cheese and guns. Switzerland happens to have a comparative advantage in the production of cheese. Based on that information, we are asked to identify which of the following 5 options provided is not true. That means out of these 5 options, 4 are correct, whereas 1 is incorrect. And that's the incorrect one that we have to find. So let's see what information we have. We are told that Switzerland has a comparative advantage in the production of cheese. That means it can produce cheese at a lower opportunity cost than United States. So therefore, this statement is correct. But that is not the answer because the question is looking for an incorrect statement. Okay, so since we know that Switzerland has a comparative advantage in the production of cheese, it cannot have comparative advantage in the production of guns, which means USA has comparative advantage in the production of guns. So B as a statement is also correct. And since USA has a comparative advantage in the production of guns, it means it can produce a gun at a lower opportunity cost than Switzerland. So therefore, A is also a correct statement. So we are now left with D and E. Switzerland must hold an absolute advantage in the production of cheese. Now, if you recall, absolute advantage is when a country can produce something more efficiently than the other country. Now, just because Switzerland has a comparative advantage in the production of cheese doesn't mean it has absolute advantage as well. Absolute advantage actually has nothing to do with comparative advantage. So this is an incorrect statement and is the answer that we're looking for. But let's wrap up our discussion with the last option. Trade is mutually beneficial for both countries. So as long as one country has a comparative advantage in the production of something, that means the other country has comparative advantage in the production of something else. So therefore, they will be specializing in the good they have comparative advantage in, and a mutually beneficial term of trade will be between the opportunity costs of any given product, right? So therefore, trade will be mutually beneficial for both countries as well. So this is also a correct statement, with D being the only incorrect one and being the answer to this question. In this question, we are not given a table of the production possibilities of Max or Jane, but with the information provided, you can make one, and I would recommend that you do so. So once you've drawn the table and we know that Max can produce 10 shirts or 8 trousers, whereas Jane can produce 20 shirts or 10 trousers all in a single month, we can figure out who has comparative advantage in what and who has absolute advantage in what. So let's do absolute advantage first. Since Jane can produce more shirts than Max in 1 month, she has absolute advantage in shirts. She also produces more trousers than Max. 10 is better than 8. So Jane has absolute advantage in the production of both shirts and trousers. So that helps us eliminate a bunch of options. So for instance, you can get rid of B, C, and that's about it, because the rest are about comparative advantage. So we do know that Max has neither a Max doesn't have an absolute advantage in making shirts or trousers, but we don't know about comparative advantage yet. Okay, so the options are between A, D, and E, but we need to figure out comparative advantage first. To do that, we can pick any good. So let's figure out who has comparative advantage in shirts. So to do that, the first step is find the opportunity cost of producing one shirt for both Max and Jane. So for Max, when Max produces 10 shirts, he gives up the chance to produce 8 trousers. That means to produce one shirt, he gives up the chance to produce 8 over 10 trousers, or 0.8 trousers. On the other hand, for Jane, 20 shirts, when she produces those, she gives up the chance to produce 10 trousers, meaning to produce one shirt, she gives up the chance to produce 0.5 trousers. So she gives up less than Max when she's producing one shirt. So Jane has comparative advantage in shirt production. That means Max has comparative advantage in making trousers. So therefore, you know that E would be the correct answer. While this question is on comparative advantage and trade, there is a big deviation from what we have seen before. Instead of telling us how much sausage and how much beer Germany and Argentina can produce, we are given information on how much time it takes for workers to produce 1 unit of sausage and beer for both of these countries. And this has big implications on how we calculate absolute advantage and comparative advantage. Now, absolute advantage, remember, is about producing things efficiently. So within the two countries, if one of them can produce a good more efficiently than the other, then we say that it has absolute advantage. Now, in this case, as we can see, to produce 1 unit of sausage, Germany requires 2 hours of labor, whereas Argentina requires 4 hours of labor. So we can deduce from that that Germany is more efficient at producing sausage, and therefore Germany has absolute advantage in sausage production. The same thing applies for 1 unit of beer as well. Germany requires 6 hours of labor, whereas Argentina requires 8 hours of labor. So one thing that you should notice here is if you were just going by the bigger number when it comes to absolute advantage, you would get this part wrong. So you have to understand whether the table provided is talking about the goods, the amount of goods being produced, or is it talking about how much time it takes to produce 1 unit? So be careful about that. Now, one advantage of this question is we don't really need to think about absolute advantage, because if you look at the options, they're all about importing, exporting, trade. Now, absolute advantage has nothing to do with trade. Only comparative advantage determines whether trade will take place, how it will take place, and what a mutually beneficial terms of trade will be. So how do you calculate terms of trade in a situation like this? Well, let's take a look. So there are 2 ways of doing this. One is you can calculate opportunity cost of, so you pick a good, you can calculate the opportunity cost of producing that good either directly from the table that you have been provided, so given the table that we have, or you can convert this number of hours required to produce a unit to a output table. So I'll take you through both of the process. You can follow the one that seems more intuitive to you. So first off, calculating opportunity cost without converting the table to an output table. So for sausages, Germany, let's see. So when Germany produces sausage, it requires 2 hours of labor. whereas when it produces beer, it requires 6 hours of labor. So in 6 hours, Germany can produce 3 units of sausage or 1 unit of beer. So as a result, we can say, well, 3 units of sausage or 1 unit of beer. So that tells me for 1 sausage, Germany gives up 1/3 beer. On the other hand, for Argentina, it can produce 1 unit of sausage in 4 hours, whereas it requires 8 hours to produce 1 unit of beer. So if you think about 8 hours, it produces 1 beer or 2 sausages. So it would be 2 sausages equals to 1 beer, gives you 1 sausage equals to half beer. So as you can see, 1/3 beer is a smaller number than half a beer. If you're confused about that, remember 1/3 is 1/3 is 0.33, whereas 1/2 beer is 0.5. So therefore, in our calculation, we see that Germany has comparative advantage in sausage production. So Germany will have comparative advantage. Now, another way of doing it is simply converting the amount of goods produced in a table form, right? So let's say here, find a number that sort of captures all these values. So perhaps if you take 24 hours, so in 24 hours, you will expect Germany can produce 24/2, 12 sausages, or 24/6 is 4 beer. For Argentina, 24 divided by 4 is 6 sausages, and 24 divided by 8 is 3 beer. So once you have an output table, you can follow the process we have followed before and then calculate it. But in order to save time, I recommend the first option. So now that we know that Germany has comparative advantage in sausages, we can deduce few things from there. That must mean Germany is producing and selling sausages, 1. Second, since Germany has comparative advantage in sausages, that must mean Argentina has comparative advantage in beer. So Argentina will be producing and selling beer, whereas Germany will be producing and selling sausages, and each buys what the other is exporting. So if you go back, let's check the answers, potential options. Germany will export sausage and import beer. Well, that seems to be a correct answer because Germany has comparative advantage in sausages, so it will be producing and selling those, and Argentina has comparative advantage in beer. So what about exporting both, right? So thing is, neither Germany or Argentina will ever export both. You specialize in trade and export only one of those goods. The only time when you may think, oh, what if you have comparative advantage in both goods? That cannot happen. That means you have the lower opportunity cost for both just by how slopes work in a production possibility frontier. That is not possible. It is possible that your opportunity cost is the same as the other country's opportunity cost. In that case, there's no need for trade. People would just be producing on their own PPF. So therefore, a country exporting both of an item, that like both sausages, both beer in this scenario, that is something that can never happen. So this would be impossible. And you will always have a mutually beneficial trade being a possibility whenever you find that countries have comparative advantages in different things. So therefore, this can also be ruled out. So that tells us how to find the answer to this kind of question. People and economies have a choice. Should they be self-reliant, producing every single thing they want to consume? Or should they specialize according to comparative advantage and trade with others? Nowadays, we only see people and countries specializing and trading with others. And the reason behind that is by specializing according to comparative advantage and trading, each country and each person can produce on their PPF but consume outside it. Why does that happen? So let me explain this to you using an example. So let us say USA has a competitive advantage in the production of laptops. It can produce laptops or phones, but it has a competitive advantage in laptop production compared to, let's say, another country. And hypothetically, let's say it can produce 100 laptops or 100 phones using the resources that it has. Okay. For simplicity, let's assume that USA only produces laptops. So it is, in our diagram, it is producing 100 units of laptops. And it is trading with its trading partners at a rate of 1 laptop for 2 phones. So that means when USA, with a competitive advantage in laptops, sells 1 laptop, it gets 2 phones in return. Now, this opens up an interesting possibility when it comes to trading. That means what you produce is not what you consume. So for instance, USA is producing 100 laptops and no phones. But if it sells 50 laptops, so it will only have 50 laptops left for consumption while selling the remaining 50. It will get 100 phones in return based on the terms of trade mentioned here. So by selling 50 laptops, it gets 100 phones. So it happens that USA will now, in this situation, be consuming 100 phones and 50 laptops, so somewhere here. And this illustrates, so this is 100 units of phones and 50 units of laptops. So this illustrates that while the USA is still producing on its PPF, so it is producing here, remember, it gets to consume outside it. What if the USA chooses to sell all its laptops? So that means it produced 100, sold 100, so it's left with 0 units of laptops for its own consumption. But in return for those 100 laptops, it gets 200 phones. So that means it is now able to consume 200 phones. So that this orange line that I've drawn shows the consumption possibilities based on the term of trade mentioned here. If the term of trade changes, the consumption possibilities will change. But one key aspect here is that USA is still producing on its PPF, but is now, through specialization and trade, is able to consume outside it. So that makes C the correct answer. But let's go through the rest of the options to sort of understand how they would impact our PPF. First, specialization trade makes a country less reliant on other countries. That is not true, because by specializing in trading, you are reliant on buying things from other countries and also reliant on them buying from you. So that would not be the correct answer. Benefit from a shift of its production possibilities frontier to the right. Now you may say the diagram makes it look like there's a shift, right? Well, the orange line is only showing consumption possibilities. It's not showing the production possibilities. Production possibility curves or frontiers can only shift if there's an increase in the quantity or quality of resources available, or if USA saw an improvement in its technology. So trading does not increase production capacity and thus PPF in any way. So you can cross out B. D, produce beyond its production possibilities frontier. By definition, PPFs show the production capacity. You cannot produce beyond that, because if you can, then you have drawn the production capacity in an incorrect manner. By definition, you cannot produce beyond your capacity. So therefore, this can be crossed out as well. Lastly, become productively efficient. Productive efficiency means, in the context of production possibility curves, that the country is producing somewhere on the PPF. So as long as it does that, it is productively efficient. This has nothing to do with international trade or competitive advantage and all that. What allows an economy to consume beyond its production possibilities frontier? Now we know that can be done if the economy specializes in the production of goods in which it has competitive advantage and trades within a favorable term of trade with trading partners. Now, if you look at the options available, the only trade-related one is option B. So suffice to say that should be the answer. But of course, sometimes you may have other options as well. So we need to go through these options one by one and figure out what they're saying. So option A. What happens when you produce more capital goods? So capital goods are a factor of production. If you produce more capital goods, the economy's resources will increase, which will in turn shift the PPF outward, allowing the country or economy to consume beyond its PPF that it has right now. Now, the question says, what would allow it to consume at present? Allow the economy to consume beyond its PPF at present. So producing more capital goods can help do that in future, but not now. That is why this is not a correct answer. Option C, a fall in the unemployment rate. Now, this is a tricky one because students often feel that if unemployment rate falls, the economy is producing more, so you can produce and consume more. That is not true. The PPF shows the production capacity. It doesn't show where the economy is currently producing. So even if everyone is unemployed, the PPF stays the same. If unemployment now drops to half, PPF stays the same. If unemployment is 0, PPF stays the same. That's because the PPF is drawn assuming the economy is using all its resources fully. It's the capacity, not production point. So a fall in unemployment rate would perhaps make the production point shift from inside towards the PPF. So more resources are being utilized. So you're producing nearer to your capacity, but it actually doesn't do anything with regards to the PPF or the capacity itself. So therefore, that is also incorrect. Producing goods in which the economy has an absolute advantage. Now we know that the specialization should happen according to comparative advantage, not absolute advantage. So you can leave that out. E, when all factors of production are fully employed, otherwise known as the economy is productively efficient and it's producing somewhere on the PPF. So just because an economy is producing on the PPF doesn't mean it can consume beyond it. So this would also be incorrect. Now, what does option B say? Purchasing goods from foreign economies at a term of trade that is less than the economy's opportunity cost. So there are a lot of terms here and it can get confusing. So let me help illustrate this option by looking at an example that we did in the previous question. Okay, so in this question, we talked about how the United States can produce laptops or phones. It can produce 100 units of each. This is a hypothetical scenario. And in this scenario, we said US has a comparative advantage in laptop production. So therefore, if it was producing 100 units of laptop, it cannot produce beyond its PPF. It was producing 100 units and it was selling it to a trading partner at a term of trade of 1 laptop for 2 phones. I discussed this in detail in the previous video, but if you want to not go back to that, you can read the stuff I've written here. It explains the exact same process. Now, in this story, what we see is while USA had to produce on its PPF, it could consume beyond it. How? Because for every laptop it sold, it got 2 phones in return. So let's say USA produced 100 laptops. It sold all 100 of them, leaving nothing left. But instead of getting 100 phones, it got 200 phones in total. Because remember, it was trading with its trading partner at a rate of 1 laptop for 2 phones. This is a hypothetical terms of trade. So if it was able to do that, it means that USA could consume on the orange line while producing on the black line. So the black line shows the production possibility curve. The orange line is showing the consumption possibilities based on the terms of trade suggested. Okay, so this sort of explains why or how an economy can consume beyond its PPF while producing on it. But of course, if you go back at the option provided, it doesn't say that, right? It's bringing in terms of trade and opportunity cost. So let's dig deeper into it. This happens. So there are 2 ways of looking at it. First is USA is being able to consume outside PPF because it is getting a better trade-off or better terms of trading with partners compared to what it gets in its own production possibility curve. So for instance, in this example, USA is simply getting 1:1. So 1 laptop for 1 phone. This is the term of trade USA gets for its own PPF, right? If you look at the black line, that's what it can produce and consume. So as long as it gets a better rate than that, so it's producing laptops. So per laptop, if it gets more than one phone, that means USA would benefit because it's getting a better trade or opportunity cost in that sense. It's getting a better term of trade with others compared to what it can get for himself. So that is about the selling aspect. What about the buying aspect? So since USA has a comparative advantage in laptops, it sells laptops, but it buys phones. All right. So if you consider the phone's opportunity cost, so for USA, when it makes one phones, it sort of has to give up one laptop. So if it is buying phone, it would want to pay less to its trading partners than it pays itself. So this is the payment for each phone for USA on their own PPF. So if it would be very happy if it could buy a phone at a price of less than one laptop. So when you're selling, you want better than your opportunity cost of producing that. And when you're buying, you want lower than what you would pay on your own PPF. So if you look at these options, all it says is you would want to sell goods to foreign economies at a higher term of trade than your own opportunity cost. And you'd want to buy from foreign economies at a term of trade that is lower than your opportunity cost. These are written out here, and in the options available, option B is talking about the buying aspects. You would want to buy from foreign economies at a term of trade that is less than what it would take you to produce yourself. You want a better price than you would get on your own PPF when it comes to buying. In this question, we are being asked to find the right quantity of doing something. A household is figuring out how much carbon emission it should reduce, and it has a total benefit table, and we know for every unit of carbon emission reduced, it costs the household $1,000. All right. Now, how do you find the right quantity in a question like this? You may recall, to do that, you are looking at the quantity where marginal benefit is equal to marginal cost, but there's a bit more nuance to it than that. So let's try to find the marginal benefit and marginal cost first, and then see what this means. So first off, the marginal cost. It's straightforward. For every unit of carbon emission reduced, it is $1,000 each. And what is the marginal benefit? Well, marginal benefit is the benefit you're getting from an additional unit. So when the first unit of carbon emission is reduced, the total benefit is 3,000. So that's the benefit you're getting from reducing the first ton of carbon emission. So 3,000 minus 0. So this is 3,000. Now, when a total of 2 tons of carbon emission is reduced, we see that the total benefit to the household is 5,200. Now, that is for the 2 units combined, but what is the benefit from the second unit or second ton of carbon emission reduced? Well, you can find it by subtracting the total benefit of 2 tons. So you can subtract the total benefit of 1 ton from the total benefit of 2 tons. So 5,200 minus 3,000 is 2,200. That is the marginal benefit of reducing the second ton of carbon emission. Okay. What about the third ton of carbon emission? So we see when the total benefit of reducing carbon emission of 3 tons is 6,600, and we know for doing so for the 2 units is 5,200. You subtract it, then you will find 1,400 is the marginal benefit of reducing emission of the third unit of carbon. So you go on like that, and you find the marginal benefit for each specific unit of carbon. All right. So we know the optimal way to find a quantity is to find the point where marginal benefit and marginal cost are equal. But if you look at it, we don't have any such quantity. So what do you do? The idea is, as you should continue to do an action as long as the marginal benefit is greater than marginal cost, because it means for that unit, the benefit you are getting is higher than the cost of doing that unit. So usually you stop when you reach MB equals to MC. But what if you don't have a point, such as in this scenario? Then you just stop before that. So in this case, you'd be stopping at reducing carbon emission by 3 tons because marginal benefit is still higher than marginal cost. But for the 4th ton, marginal benefit is smaller than marginal cost. So the household will be making a loss. So the household would not be doing that. So if you find yourself in a situation where you cannot do marginal benefit is equal to marginal cost, then just stop right before that. But let's think about what this really means. When you're trying to find the right quantity and we say, well, MB equals to MC, or stopping right before MB equals to MC is the right thing to do, what does it really tell us? It tells us that is the point where the difference between total benefit and total cost is the highest. So total cost here is just increasing by $1,000, and you can sort of see this. So what is the difference between total benefit and total cost? For the first unit, it's 3,000 minus 1,000, so about 2,000. For here, it is 5,200 minus 2,000. It is going to be 3,200. Then 6,600 minus 3,000 is 3,600. Then 7,400 minus 4,000 is going to be 3,400. And then finally, 7,900 minus 5,000 is going to be 2,900. So as you can see, the 3 units is where the difference between total benefit and total cost is maximized. So this is another way you can find the answer in case you get confused. In this question, we're being asked, what is law of diminishing marginal utility? And although the terms may sound difficult, but what they actually mean is quite simple. In economics, instead of using the word satisfaction from consuming a good, we use the term utility. That is it. So when you have, let's say, a cup of coffee, the satisfaction you get from it, we will say you're getting some utility from it. Now, for every single cup of coffee you have, you're getting satisfaction from each individual cup. From the first cup of coffee, you get some utility. From the second one, you get some utility. From the third one, you get some utility, and so on and so forth. Now, if you think about it, the satisfaction you are getting from each new cup of coffee falls as you have more and more. That is the idea behind law of diminishing marginal utility. Marginal utility is the satisfaction or utility you're getting from each individual cup. The more you have, the newer cups are giving you less satisfaction than the one before. So if you look at the options available, D says the additional satisfaction received from consuming extra or additional units of a good decreases as more of the good is consumed. So therefore, D is the right answer to this question. This question is a mix of calculating utilities and understanding utility-based concepts. So what do I mean by that? Let's go through the question first. When you consume 1 unit of a good, you are getting 80 utils. That means when the first unit is consumed, you get 80 satisfaction from it. Since there is only 1 unit that has been consumed so far, total utility is the same as the marginal utility of the first unit. Sounds good? Next, consuming 2 units of the good provides 130 utils. Now you have to be careful here. Is this 130 utils talking about the satisfaction you're getting from the second unit or from consuming 2 units? So if you read the question, it's talking about the utility you're getting from consuming 2 units in total. So when you have consumed 2 units, you are getting 130 utility of satisfaction in total. So that using that information, we know that the first unit, when we consumed only 1, our total utility was 80. Now when we consume 2 units, our total utility is 130. So that implies from the second unit alone, we got 50 utils of satisfaction. Now that we have clarified what the situation really is, let's go through the options and figure out what the answer is. First, option A. The marginal utility of the first unit is 50 utils. That is incorrect because we know from the first unit's consumption, you get 80 utils of satisfaction. B. The marginal utility of the second unit is 50 utils. We know that is the correct answer from our calculation. But although we have found the correct answer, let's go through the rest to figure out if we can learn something from those wrong options. The law of diminishing marginal utility sets in after the second unit. This law states that the more of a good you consume, the marginal utility from these newer units will keep falling, because the first one always gives us more satisfaction, the next one a bit less, the third one a bit lower than that, and so on. So if you look at our table, marginal utility started falling right after the first unit, not after the second one. So that is why this would also be incorrect. Question D, option D, the total utility of consuming 2 units is 210 utils. So you may think that is correct if you didn't understand this line. It didn't say that consuming the second unit give you 130 utils. It told you that consuming 2 units of the good gave you 130 utils. So if by chance you thought this was the marginal utility of the second one, which is incorrect, if you thought that, then you would be tempted to answer D, but that is not the right answer, because this is referring to total utility of 2 units. Lastly, consuming 1 unit of the good is better than consuming 2 units of the good. So the way you should be looking at it is, does consuming 2 units of a good give me a higher total utility than consuming 1 unit of a good? As we can see, 2 units consumption gives you 130 utils, 1 unit gives you 80. That tells you you are better off by consuming 2 units rather than 1. So therefore, this is also incorrect. This is a very similar question to the one we just did right now. So it says, if consuming the first unit of a good yields 50 utils and consuming the second unit of the good yields 30 utils, which of the following options is correct? So one difference from the previous question is, here both the information provided about the first unit consumption and the second unit consumption, they're talking about the marginal utility. So it sort of shows you the wording that you may see when you are provided with marginal utility values instead of total utility values. So when you consume the first unit, you get 50 utils. Then your total utility is also 50, because so far you have only consumed 1 unit, and that unit's marginal utility is what you have got in total. Now, when you have consumed the second unit alone is giving you 30 utils. So what is the total utility of consuming 2 units? It's the marginal utility of the first unit and the marginal utility of the second unit. So you add these two together and you get 80 utils. Now that we have our information in a graph, let's go through the options and see which one is the correct answer. The total utility of consuming 2 units is 80 utils. That is correct, so we already found our right answer, but as always, let's go through the rest to see whether we can learn from the wrong ones. The marginal utility of the second unit is 20 utils. So you may end up with this as the answer if somehow you thought you're subtracting 30 from 50. Just, there's no reason to do that, but this is just a trick way of putting it out there so that students can get tripped up. Okay. Option C, the marginal utility of the second unit is 80 utils. That is not correct, because the information provided already tells us consuming the second unit is giving us 30 utils. So that is the satisfaction you're getting from that unit alone. That cannot be 80 utils because the question states it is 30. The marginal utility of the first unit is 20 utils. Again, incorrect, because the first one is giving us 50 utils. Lastly, the total utility falls when the second unit is consumed. Total utility falling means your total satisfaction is falling. And that can only happen if by consuming something, you're getting dissatisfaction from it. Another way to put it is your marginal utility is negative. That is why you have consumed up to a point, then you consume another one, you sort of hate it. That is why your total satisfaction has gone down, because your marginal utility or satisfaction from the new unit is negative. That is dragging your satisfaction down. So as we can see, the marginal utility from the second unit, although it's lower than what they got from the first unit, it is still positive. So therefore, total utility did not fall when the second unit is consumed. Thus, E is also incorrect. The situation described in this question as a name. It's called the diamond water paradox. And the paradox states that although water is far more valuable to us, we need it to survive even, we are willing to pay much less for it compared to, let's say, a diamond ring, which we don't really need, but somehow we are willing to pay far more for a piece of diamond ring than we are for a glass of water. So that is why it's a paradox. So what is driving this behavior of humans? Well, the answer is quite simple. It's not that diamond rings are more valuable than water. It's just that the price we are willing to pay for something is not dependent on our total satisfaction from it, but rather from our marginal utility. So why are we willing to pay very less for water? That's probably because unless you're living in a place where water is very rare, you will have already consumed a lot of water. So someone giving you another bottle of water, you're not really going to value it as much because your marginal utility is already quite low from all the consumption so far. So as a result, you're willing to pay little for it. On the other hand, it's likely that you haven't consumed that many diamond rings. So your marginal utility from a new diamond ring is likely going to be quite high. Hence, you're willing to pay a high amount for it. Now, if there was a situation where you haven't had water for 3 days, you're roaming around in a desert, you're lost, in that case, you are likely going to be willing to pay more for water than a diamond ring. But the idea is, in a general situation, since we have consumed so much water, our marginal utility has fallen quite a bit. Remember, law of diminishing marginal utility. So we are willing to pay much less for a extra unit of water right now. And this is the general scenario. Compared to, let's say, a diamond ring, which we are likely not consuming as much, which therefore we have a high marginal utility, so we are willing to pay more. Now, so armed with that knowledge, let's go through the options. Marginal utility of a bottle of water is less than the marginal utility of a diamond ring. That is the answer because the price you're willing to pay is dependent completely on our marginal utility from it. Marginal utility for diamond ring is higher than the total utility of water. Total utility of water, so perhaps if you have consumed a lot of it, you add up all the marginal utilities, that is your total utility. First of all, we don't really know what the total utility of water is because we don't know how much we have consumed, what the marginal utility is. But if you put a value on your life, it's likely that total utility of water consumption has been quite high already, probably higher than your marginal utility of a diamond ring. However, once again, the price you're willing to pay is not dependent on a total utility. It's only dependent on marginal utility. So, option C, total utility of diamond rings is more than total utility of water. Once again, that we don't actually even know and is not relevant to the discussion because, once again, the price you're willing to pay is only dependent on one thing and one thing alone, which is marginal utility. All right. Marginal utility of a bottle of water is greater than the marginal utility of a diamond ring. If this was true, then you would be willing to pay more for the water, not less than the diamond ring. Lastly, Jack is irrational and fails to understand that water is more valuable than a diamond ring. Now, you can make that argument, but in general, in economics, we assume that people are acting rationally. So therefore, this is not the right answer because we do have an explanation why even a rational person may be willing to pay more for a bottle of more for a diamond ring than a bottle of water, and it all has to do with the relative marginal utility. This is a calculation question on utility, and it's a fairly common one that you will come across in the AP Microeconomics exam. In this question, we find that Emma can buy two goods, either chocolates or fruits. She has a set amount of budget, and she's currently buying 8 units of chocolates and 4 units of fruit. Now, the question is asking, given the current combination that she is purchasing, is it her optimal choice if she wants to maximize her utility? So to find the answer to this question, we need to check the marginal utility per dollar that Emma is getting from chocolates and fruits and comparing them. If we find that one is higher than the other one, that means Emma can increase her utility by buying more of the good that has higher marginal utility per dollar and buying less of the good that has the lower marginal utility per dollar. So let's take a look. Currently, Emma is buying 8 chocolates, and her marginal utility for the 8th chocolate is 8 utils, and the price of chocolate is $1. So that means her marginal utility per dollar from chocolates is 8 divided by 1. So that is 8. On the other hand, for fruits, he has bought 4 fruits, and her marginal utility for the 4th fruit was 20. And her price of the fruits is $2. So it should be 20 divided by 2. So that is 10. So that means per dollar spent, if she spends it on fruits, she gets 10 utils per dollar. Whereas if she spends it on chocolate, she gets 8 utils per dollar. So if her goal is to maximize utility, then she should have been buying more fruits and less chocolates. That way, she would be able to maximize her utility. So if you look at the options, the answer to that question should be buying more fruits and fewer chocolates. So D is the correct answer. This is a variation of the utility calculation question that we have seen before. So in this story, Grace can buy 2 goods, cookies and orange juice. She has a set amount of money, and we do not know the prices of the goods that she's buying. Instead, we do know the marginal utilities that she's getting from the last unit bought. So for cookies, she's getting 30 utils from the 20th cookie that she's eating, and from the juice, she's getting 10 utils from the 10th can that she's drinking. Okay, so the options provided to us have some information on prices, and they are giving us some prices and telling us in those situations what should Grace be doing in order to increase her total utility. So before we get into the options, let's think about the concept. We know in order to maximize utility, total utility, with a given amount of budget, every additional dollar should be spent on the good with the higher marginal utility per dollar. So that means spend your extra dollars on the good that is giving you more satisfaction or utility per dollar compared to the other good. Okay, so we do not know the prices, but we do know that marginal utility, if the prices are the same, let's say we start off from there, if the prices of cookies and juice are the same, for simplicity's sake, let's say they're $1 each. If that is the case, then the marginal utility per dollar from cookies is higher than marginal utility from juice. So Grace should be allocating more money to cookies by taking away money from juice until they sort of become equal. That is sort of what we would expect would lead her to increase her utility. So if you look at the options, the first one says, consuming more orange juice and less cookies if prices are the same. We just discussed it's the opposite that would happen. If their prices are the same, the marginal utility per dollar from cookies is higher than marginal utility per dollar from juice. So in that case, you should be buying more cookies, not less. Okay, so A is not the right answer. Let's look at B. Consuming more orange juice and less cookies, the price of a cookie is triple that of a can of orange juice. Remember, we don't have the prices, right? But for calculation purposes, what you can do is put down values. So let us say price of a cookie is triple that of a can of orange juice. So if it was $3 cookie and the can of orange juice is $1, so let's see what we have. Marginal utility per dollar from cookies is 10. Marginal utility per dollar from juice is also 10. In that case, she should continue to consume what she currently is consuming and not change it. So therefore, this is also incorrect. Option C, consuming less orange juice and more cookies if the price of a cookie is triple that of an orange juice. This is also incorrect because this is the same scenario we just looked at right now, where the price of a cookie is triple that of a can of orange juice. But as we know, in that situation, she should continue to consume whatever she was. She cannot increase her utility by doing anything else because her marginal utility per dollar are equal in this scenario. Okay, option D. Consuming less orange juice and more cookies if a can of orange juice is $2, whereas cookies are $3 each. So in that case, 10 divided by 2 is 5, and 30 divided by 3 is 10. So in this situation, we see that the marginal utility per dollar from cookies is higher than that from juice. So she should be buying more cookies and less orange juice. So in this case, the answer is going to be D. In this question, we see that Hamid is trying to maximize his total utility, and he's currently buying sodas and burgers with his weekly allowance. The question is asking how Hamid can maximize his total utility based on the information provided in the question and also in the options. So let's see what is happening. So Hamid is currently buying 6 sodas and 6 burgers. His marginal utility from the last soda is 20 utils, whereas his marginal utility from the last burger is 40 utils. So based on that, we don't really know whether he's maximizing his total utility or not because we do not have price information. Remember, with a set amount of budget, if a consumer is trying to maximize the total utility or total satisfaction they can get, they need to spend every single dollar on the good that's giving them the highest marginal utility per dollar. So they keep doing that until they run out of the budget. And what happens is, as you buy more of a good, its marginal utility falls, and eventually the marginal utility per dollar across all goods becomes similar. But in the process of doing that, you are getting the highest marginal utility possible for every dollar spent, adding up to the highest total utility you can get. So here we don't know whether Hamid is currently at that point, but let's look at the options to figure that out because they have information on prices. So option A says Hamid can maximize his total utility if he maintains his current level of consumptions, provided the price of soda is $2 and the price of a burger is $4. In that situation, the marginal utility per dollar from soda and burger happens to be the same, and it is indeed the right answer because if Hamid wants to maximize his total utility, he can't really do better other than equalizing the marginal utility per dollar on both goods. If you look at option B, where the price of a burger is $2, whereas the price of a soda is $4, in that situation, you will find that the marginal utility per dollar is vastly different. So marginal utility per dollar from burger is 20 in that case, and 5 in this case. In that situation, Hamid should be buying a lot more burgers and taking away money from soda purchase. So that means buying less sodas and more burgers. So maintaining his current level of consumption would not be the thing that he should be doing if he wants to maximize his total utility in this situation. So this would be incorrect. Lastly, if you look at options C, D, and E, they suggest different things that Hamid should do, but says that he should be doing those regardless of what is happening to prices. Now, with a set amount of budget, prices are very important if you're trying to get most bang for your buck, so to speak. So as a result, when you're trying to maximize total utility with a small amount or whatever, a finite amount of budget, in that case, prices are super important. So therefore, whenever you see options like this, you know for certain they are not the answer. So C, D, and E, you can cross out simply because they're saying, regardless of prices, he should do something. In this question, we have Alex deciding to spend his entire income on buying 2 goods only, concert tickets and console games. Then we are told that the prices of console games and concert tickets both double and his income actually increases by 4 times. So what should Alex do in this situation? That is the question. Now, this is a tricky question, so we'll break it down into 3 parts. In the first part, we'll talk about where he starts out. Next, we'll think about what happens when the price of both goods doubles. How does his consumption change? And in the last part, we'll talk about how things change when his income actually goes up by 4 times. So let's get started with the first situation. A key thing to remember is it doesn't matter what the price of the goods are, doesn't matter what the amount of income is. Whenever people are spending money, they're spending their budget based on what is giving them the highest marginal utility per dollar. So if you have 2 goods, you pick the good that's for every single dollar you spend it on the good that's giving you the highest marginal utility per dollar. But if you keep doing that and keep buying that good, what will happen is your marginal utility from buying it will fall. This is because of law of diminishing marginal utility. So while the marginal utility of that good keeps falling as you keep buying more and more of it, eventually what we would expect is no matter what your income is, the marginal utility per dollar should become roughly similar across all the goods that you have available for purchase. So if you're buying concert tickets and console games, no matter what your income is, no matter what the prices are, we will expect that the marginal utility per dollar across both goods should become roughly similar. Okay, so this is the initial situation where we begin in Alex's story. He's spent this money in such a way so that his marginal utility per dollar across concert tickets and games are roughly equal, and that has maximized his total utility until this point. Okay, next up, what happens is the prices of both goods have doubled. Now, if prices of both goods have doubled, if they have both doubled, it means the marginal utility per dollar from concert and games have actually stayed has stayed equal to each other, but they don't necessarily have to be the same value. The values themselves may have changed. So what I mean by that is when the prices have doubled while his income has stayed the same, let's say his income is $100 and it stayed 100, but prices doubled, we can say that his money will fetch fewer units of both. So he'll be buying less concert tickets and less console games when prices doubled while his income stayed constant still. Okay, so if he's buying less of both, that means his marginal utility per dollar from both of these goods will actually be higher. Remember, he's buying less, so that means he's still in his first few units where his marginal utilities are still higher. Okay, so now as his marginal utility per dollar across concert tickets and console games, while they're higher, remember they would still be roughly equal to each other. The reason is no matter how much money you have, no matter what the prices are, you're spending every single dollar in that same way. And this idea that no matter what the prices are, no matter what the income are, your marginal utility per dollar will sort of equalize or stabilize is one of the insights of this entire exercise. Okay, so we have done our second scenario. We understand when prices double, then he's buying less of both goods, but the marginal utility per dollar for concert tickets and console games should roughly be the same to each other, roughly be equal to each other. Okay, now that Alex's income has gone up by 4 times, let's say he had $100 before and he was spending on those units, on those 2 goods. Now he has $300 more to spend. In that case, he will start spending on the good that's giving him the highest marginal utility per dollar. He will keep doing that, but once again, even though he has $400 now, the end result is the same. The marginal utility per dollar from concert tickets and console games will again roughly become equal. Okay. Now, what that tells us is compared to his previous situation when prices doubled but income went up by 4x times, he in real terms had more money to buy. So prices went up by twice but income went up by 4 times. So in reality, his ability to buy things went up by roughly twice. So if that is the case, that means he ends up buying more goods. Now you may say, well, does he buy twice as much as before? He doesn't. He would only do that if the marginal utility curves for concerts and games were identical. What do I mean by that? Think about this. Let us say his marginal utility per dollar was at some level. Now he has more money. Sure, so now he's spending on either of those goods. Let's say he buys concert tickets and the marginal utility falls sharply. On the other hand, then he would be going to buying games next, as the marginal utility per dollar from games is still not that low. But what if the marginal utility of games doesn't fall as quickly? So he keeps buying that, keeps buying that, keeps buying that. We know with this extra income, eventually the marginal utility per dollar will become equal, but we do not know what the marginal utility values are based on the information that we have. So as a result, we just know he will be buying more of both goods. We don't really know whether the ratio in which he was buying them would change or not. So as a result, if you go back up here, the answer to this question is not buy twice as much. It will just be buying more of both console games and concert tickets. If a good is given to you for free, how much of it should you consume? Well, if I assume that your goal is to maximize your satisfaction or total utility, I will say that you will keep consuming a good as long as the newer units are giving you positive marginal utility. Because when you get positive marginal utility from any unit, that means your total satisfaction or total utility is going up. Remember, positive marginal utility means that from the unit that you're consuming, you're at least getting some satisfaction. On the other hand, when your marginal utility becomes negative, that means you sort of hate that unit in particular. So maybe you have up to 5 cups of coffee. For each cup of coffee, your marginal utility was positive. That means you got satisfaction from each single cup, from first to the 5th cup. And let's say the 6th cup, your marginal utility becomes negative. That means the 6th cup sort of makes you sick and you don't really want to have it. So even if you get the coffee for free, you'll stop at the 5th cup when your marginal utility was at least greater than 0. So what happens when you consume a good that has negative marginal utility? That means your total utility starts falling. So if you look at the options available, we do not have as long as marginal utility is positive, but we do have a case where marginal utility is 0. So marginal utility will be 0 right before turning negative. So this is the correct answer. Why not total utility becomes negative? That just means that so let's say for the first 5 cups of coffee, you had positive marginal utility for all of them. So you add them all up, you get a large total utility. So you don't stop until your total utility becomes negative. You stop at the highest point of your total utility, when your total utility is maximized. And that will happen as long as marginal utility is greater than or equals to 0. You won't wait until total utility itself becomes negative. So that is why C is not the right answer.